Hello guys, welcome back to the channel. Today we will be learning about how to extract lithium from one of these CR2032 batteries. So there's a lot of ways to get lithium from batteries. One of the most common ones is, I think, the Energizer Ultimate AA battery, which gives you a lot more lithium. But I guess today is just an experiment to see how we can extract a little more of the uncommon metals from everyday objects. So here you go. And so you're probably asking, why am I doing this, right? Why do I want to extract lithium from batteries? Well, it turns out one of the processes for making potassium metal has to do with having another alkali metal that can do a single replacement reaction with potassium chloride in something called an alkali metal converter in order to get potassium metal. And obviously potassium metal is really expensive, and so that's why this will be part of a series where I'll be working on my way to producing cheap potassium metal. And so one of the most common alkali metals we can use is lithium, and that's what we're going to be extracting today. Now, it's important to note here that we're dealing with some pretty dangerous chemicals. Obviously, we have lithium, which is located at the anode of the battery. And also, if available, you should probably use non-metallic tweezers. That would be ideal, but I don't have them, so I'm gonna be using metal tweezers today. And the reason why I suggest non-metallic tweezers is because these batteries have an anode and a cathode, and the reason why they use lithium is because it's more effective. I know lithium has a really high reduction potential, which is why they use it in batteries. And so the thing is, if we actually were to connect the cathode and the anode with the metal, the electrons would flow through, it would react with the lithium and actually create a very dangerous explosion, which is why we have to be very careful while we're doing this. Now, these batteries have several parts. As I take it apart, I will educate you about the different purposes of each of the parts. So here we go. So the first thing you're going to want to do is, you see a little crevice at the edge of the battery. You're going to want to clamp that really hard and just twist it really hard to the side so that the top of the battery and the bottom of the battery separate. And so you're gonna create a crease there, and what you want to do is kind of work your way around about maybe 2/5 of a way when you have this gap, and then you might be able to pry it open with a screwdriver. If you don't have screwdrivers available, I guess just pry all the way around and pull it without your fingers, but let's get into it. Now, the first thing you'll notice here is that there's sort of a black substance, and we can see some sort of a metallic mesh that separates a slightly grayer substance from a blacker substance. And so the chemical above the mesh is magnesium dioxide, which serves as the cathode, and the mesh basically separates it from a bridge that allows electrons to flow through, and this is how batteries store electric potential energy. And so one of the advantages of being able to pry it open from the sides like this is that the metal doesn't get very much contact with the parts of the battery. So there's a very low probability that you're making an electrical connection between the anode and the cathode. Okay, so as you can see here, I kind of destroyed this separator. This is what the separator looks like. It's kind of just a mesh. It still has some magnesium dioxide. And so these are used batteries, so they may, the products may be bad, but this is the best we can do. Then over here, we can see that this is the bottom side of the battery because it has these array of dots, which signals that this is the side with the anode, which means it's going to have lithium. And so all we need to do is scrape off the manganese oxide. And now it's time to test if this is actually lithium. Okay guys, now let's actually see how much damage this can do. For the moment of truth, is it really lithium? Oh! That's insane. Let's bring it to the surface. It might flame. Never mind, actually. That's a very small amount. It's probably not going to flame. Hey, still cool though.